Look here in section 12.2, graphing rational functions. We're going to kind of build off of what we discussed today in class regarding inverse variation. So we're going to continue those discussions on graphing here. And so you'll notice here the parent function for simple rational functions is just f of x equals 1 over x, or y equals 1 over x. Remember, the name of the graph is a hyperbola, very similar to how a quadratic, the name of the graph is a parabola. The name of a rational functions graph is a hyperbola. It has two symmetrical branches, okay? You'll notice here the domain of the parent function is x cannot equal 0, and y cannot equal 0 is the range. So you'll notice this guy right here, screw that up, give me 1 second. Alright, see if we can get this right. So, x equals 0 is your vertical asymptote. In other words, your x values can never be 0 because these graphs will get infinitely close but will never hit that axis. And by the same argument, y equals 0 is your horizontal asymptote because, again, your graphs will get infinitely close to those lines but never actually touch. So remember, the word asymptotes there simply means that those are lines that your graphs will never hit, but they'll get really close to. Alright, so graph y equals 4 over x. Okay, notice we don't go left, right, up, or down, or anything like that. Okay, this 4 is going to treat this, or do the same thing to this graph that A would do to any other graph, and that is it's going to stretch it. Okay, but the domain is still going to be x not equal to 0, and your range is still y cannot equal 0. Alright, your asymptotes will be x equals 0 and y equals 0. Okay, so in other words, before I even graph this, I know immediately that my graph will get infinitely close to but never touch those two red lines. Okay, so now as I go and I want to graph this thing, I'm going to create a table of values. Plug in -2 for x, you'll get out -2 for y. Plug in -1 for x, you get out -4. Plug in 0, you're undefined. We already knew that x can't be 0. When you plug in 1, you get 4. Plug in 2, you get 2. Alright, so you plot these points. -2, -2, -1, -4. And so this guy is going to look something like this, and the other side will be 1, 4, 2, 2, so it's going to look something like that. And that would be the graph here. That's all we're looking for. Give me the domain, the range, the asymptotes, plot some points, and connect the dots. Alright, so now we're going to get into similar to the same progression we've done with every other graph. Okay, so here's the parent graph. Okay, now let's move it left, right, up, down, stretch, shrink, flip it, everything else. Okay, so you'll notice here this A value on top is still going to be your stretch or shrink. Okay, and if that A is negative, it's going to take your graph and it's going to reflect it, so it's still got the same properties as anything else. Now what you'll notice here is this guy down here will determine if you go left or right. Okay, and it's very similar to what we've already discussed in the last chapter, and that is if it's x minus h, okay, the h moves it, it's the opposite of what you think. Okay, so if you think that if it's x minus 4, that means it actually moves it to the right 4 units. Okay, same thing if it's x plus 2, as in the first example here, it's going to move it left 2 units. And you'll notice that those also give you your asymptotes. Okay, so in other words, before I do anything here, if it says draw a sketch, okay, I know right away what my asymptotes are. Remember, your vertical asymptote is just x equals whatever this value is. Okay, and again, it's the opposite. So since that's positive 2, the vertical asymptote is x equals -2, and the horizontal asymptote is y equals -1. Okay, so in other words, at x equals -2, and at y equals -1, those are now the asymptotes of my graph. In other words, I've taken my graph and I'm going to go left 2, down 1. Okay. Furthermore, that changes your domain. Okay, your domain is very simply x cannot equal -2, and your range is now y cannot equal -1, but it can hit everything else. And finally, excuse me, I want to create a table of values, so I have x, and y, and so I want to go probably maybe 2 units to the left and 2 units to the right of that asymptote. So let's let x equal -3 and -4 and see what happens here. So when x is -3, -3 plus 2 is -1, 4 divided by, that's -4, and when x is -4, oh, I forgot to subtract the 1. So when x is -3, we have -3 plus 2, which is -1. 4 over -1 is -4, minus 1 is -5. And then when I plug in -4 for x, -4 plus 2 is -2. 4 divided by -2 is -2, minus 1 is -3. So I have -3, -5. So that point right there. And I have -4, -3. Right there. And so if I'm just going to do a quick sketch, we'll say this is going to go up this way, down this way, and then furthermore I want to go to the right of the asymptote as well. So my asymptote is -2, so I want to go -1 and 0. When I plug in -1, okay, -1 plus 2 is 1, 4 over 1 is 4, minus 1 is 3, and 0 plus 2 is 2, 4 divided by 2 is 2, 2 minus 1 is 1, so I have 0, 1, and I have -1, 1, 2, 3. And so this side of the graph is going to be something like that. And that's all we're looking to do when we're sketching. Okay, draw a sketch of y equals -3 over x minus 1 plus 2. Okay, so again, identify your asymptotes. X equals 1, right, opposite of what you think, and y equals 2. So your domain and range are just cannot equal those. So x cannot equal 1, and y cannot equal 2. So I know my asymptotes now. X equals 1, y equals 2. Okay, and then I want to create a table of values. So you have your x and your y. Let's go 2 to the left and 2 to the right of our asymptote. So if I go 2 to the left of x equals 1, I get x equals 0 and -1. So let's figure out, plug those in. So I'll plug in 0. So I get 0 minus 1, which is -1. -3 over -1 is +3. 3 plus 2 is 5. Okay, and then I plug in -1, I get -1 minus 1, which is -2. So I have -3 over -2, that's positive 1.5, plus 2 is positive 3.5. Alright, so 0, 5, 1, 2, 3, 4, 5, and -1, and 1, 2, 3.5. And so you'll notice the hyperbola is going to be something like this, and the other side is going to be a mirror image of it, but let's just go ahead and plot points anyway. Okay, let's go 2 to the right, so x equals 2 and x equals 3. 2 minus 1 is 1, -3 over 1 is -3, plus 2 is -1, so I have 1, 2, -1, and at 3 I have 3 minus 1, which is 2, -3 over 2, so that's -1.5, plus 2 is positive 1/2, so I have 1, 2, 3, and positive 1/2, and so this hyperbola would look something like that, and we knew it was going to be the opposite because that negative right there is going to flip it. Okay, so again, we'll look more at these graphing tomorrow in class, but just wanted to kind of give you guys a brief rundown and an idea as to how to graph these rational functions.